Okay, today we're going to add vectors again, and we've already done this. What makes this problem different, we have a negative angle instead of a positive angle. We have a negative magnitude instead of a positive magnitude. But the technique is what it was. Okay, I'm going to change from polar to rectangular form to get both of these vectors into IJ rectangular form. Alright? So, I'm going to use my calculator. I want to make sure I'm in degrees, not radians. My calculator says I'm in radians. The newer calculators have it up on the top. The older calculators don't. If you just hit mode, you can see whatever one's highlighted is the one you're in. So you just go down here to degrees, slide over there, hit enter. Now it's degrees instead of radians. And r cosine theta, r sine theta give me the two numbers I need, the I vector, the j vector here. So if I do negative 4 cosine negative 20 and negative 4 sine negative 20, and the signs are important, so 4 is negative, the 20 is negative, make sure those signs are what they are. We get this vector here is equivalent to negative 3.76 I plus 1.37j. And just a reminder, the book likes to use R and U instead of I and J. The I vector is a vector goes to the right. The J vector is a vector that goes up. That's the R and the U they're talking about. Every other math book in existence uses I and J. I'm going to use I and J because I don't want to train you on one thing this year and then next year we jump to I and J. Like, what's that? So we'll just use I and J. Just pretend the book doesn't know what it's talking about on this one. That happens occasionally. All right, the second vector, 5, 135, so I do 5 cosine 135, and then 5 sine 135, and we get our I and J vectors there. Negative 3.54 for both, or sorry, one's positive, right? So negative 3.54 I vector and positive 3.54 J vector. All right, so that's priority one. Get both vectors into rectangular form, which allows us to add the components together to get a resultant vector. These are both positive, so I add, make it negative. These are both positive, same sign, so I add, get a positive. So negative 7.30 I plus 4.91 J is the resultant vector in rectangular form. What I want from you is to go back to polar form. The book stops there. Again, this in my opinion, the book is a little lax on this entire topic. Okay, this coordinate conversion topic. They're really lax. They use R and U instead of I and J. They leave everything in rectangular form. You can just easily go back to polar form. I like the extra practice you get going back to polar form. And this again is something we've been doing here for a while. So, and I really consider 3 and 4 to be the same step. Well, I guess 4 is right the answer, but steps 1, 2, and 3 get you what you need. You're looking for R and theta. Step 1 gets you R. Step 2 gets you a reference angle, which helps you find theta. Once you have R and theta, you write the answer. That's how we go. And I've said this countless times, and some people are still not doing this, so obviously people aren't listening to me, so I'm going to say it again. Hopefully everybody can listen to me now that I've just said people don't listen, and you're going to I'm challenging you. You guys never listen to me. Challenge accepted. All right, so h squared and b squared are always positive. Do not ever write negative signs in step 1. Absolute value bars make things positive. Do not ever write negative signs in step 2. The only place negative signs matter is step 3. What quadrant am I in? All right, that's the only place the minus sign matters. So when I do step 1 here, it says r equals the square root of h squared plus b squared, square root of 7.30 squared plus 4.91 squared. Do not write minus signs in your work there, because your calculator, if it says negative 3 squared, let's just look at that. Your calculator thinks that equals negative 9. It actually equals positive 9 if we're squaring the value negative 3. That's what the rule says. So if it says h squared, it means sign and number being squared. So don't put the calculator in doubt, just let your calculator work it out. So square root 7.30 squared plus 4.91 squared, in parentheses. I type in, oops, 4.91. I type in exactly what my problem there says. 1 parentheses to begin it, the entire expression, end parentheses, enter, and that's the value of r, 8.80. That's part of my answer. just like that. Step 2. Alpha equals the inverse tangent of v over h. V is the second number, h is the first number in our form. And again, this is in your possession during a test. So if you don't know what h and v are, you can just look down at, well, the h is that one, v is that one, and just kind of compare v, h, right? Again, everything's right there in your possession, but some of you, I think, are, maybe you're panicking during a test or whatever, but some of you just aren't making those connections, but it's just right there staring you right in the face. So, and again, absolute value bars make everything positive. So step 2, alpha, this reference angle, is going to equal the inverse tangent of v over h. Okay? It does say inverse tangent, right? Not tangent. So I hit the second button, tan, so it says tan negative 1, 4.91 divided by 7.30. Again, what goes on my calculator screen is exactly what's written on my paper. Hit enter, and then notice I'm in degrees, hit enter, 33.92 degrees. A couple decimal places every time is fine with me. The answer you get for step 2 should always be between 0 and 90 degrees. Positive between 0 and 90. That's where it's going to be every time. If you get a negative answer to that, that's because you didn't listen to me and you put a minus sign in this work, which you don't do in step 2. Step 3, determine the quadrant. If you imagine an x, y coordinate, first, second, right? Negative 7.30, positive 4.91, and just imagine where that dot would go. Here's the first, second, third, and fourth quadrants. You can very easily see what quadrant we're in, right? So the negative sign moved me left, the positive sign moved me up. That's where the minus signs matter. All right? Second quadrant, it tells me exactly what to do to alpha to get theta. So second quadrant, 180 minus alpha. So step 3, what we're looking for, theta is going to be 180 minus 33.92, which equals 146.08. Step 4, write the answer. R theta. So 8.80 at an angle of 146.08 degrees. And those of us who like to check our answers in the back of the book, let me tell you something the back of the book does on this. Again, going on to my same theory about I don't think the book takes this topic very seriously. They use negative angles in final answers sometimes. This process will never get you a negative angle. It could, like, negative 30 is the same as positive 330. They're the same. I know they are. I also know you copied it out of the back of the book and put negative 30 in your final answer because I never taught you how to do it that way. So, do it this way. The answer should be between 0 and 360 on your final angle every time. If you get a back of the book answer that's a negative angle, you're checking, you're doing a legitimate check. You did all this work, right? Let's just say you did a problem like this and you ended up with 6 at an angle of 317 degrees. Let's say that's what you got as an answer. And the back of the book had 6 at an angle of negative 43 degrees. All right? If you add 360 to their angle, it should match your angle. That's it. So if they have a negative answer, negative angle answer in the book, just add 360 to it. That's what the angle you should be getting is, based on the technique I'm giving you. Right? I don't want negative angles in these problems. I want positive angle answers every time. The way I've given you, we'll do it every time. And again, this process is right there. Practice it. Get good at it. Okay, quit cutting corners on your homework. Get your homework done well. And that way when they show up on the test, they're not going to panic. You're not going to panic about it. You're just going to be able to do it. And again, your calculator is doing all the hard stuff. Inverse tangent of 4.91 over 7.30. I don't know what that equals. My calculator sure did. Right, so allow your calculator to evaluate things for you, but you need to know what to type in and how to do it. That's what you need to work on. All right, so make sure you practice it, get good at it, and hopefully those will start being right every single time.